Hello, my name is Bryn Van Dyke, and today I'm going to be talking about the history of light and optics. I chose to further my knowledge about light and optics because I really enjoy learning about how the human body works with the world around us to function. In order to understand how we see, we must learn about how light travels. I wanted to focus on the history of this topic because I learn better when I start from the beginning of time and work my way through until now. I wanted to find out how far back in time scientists started asking these questions about how light travels and how these theories developed into what we know today about light and how we are able to see with the human eye. People started asking questions about light as early as the 5th BC, and theories developed all the way until the mid-20th century with scientists like Aristotle, Ibn al-Haytham, Sir Isaac Newton, Christian Huygens, and Albert Einstein. The first theories of light were developed from 5th to 3rd BC in ancient Greece. People started to wonder if light was made up of many particles or if it was made of a wave. Although little was known during this time about light, Aristotle came up with the beginning theory that light was a disturbance of air, and the essence of light is white light, that colors are made up of a mixture of lightness and darkness. He believed that illumination itself was separate from the appearance and actions of colors. By the year 1027, a physicist, Ibn al-Haytham, who studied in Egypt, asked the question, why does the moon appear larger near the horizon than it does when higher up in the sky? In order to find an answer to this question, he experimented with light coming through a hole at different angles to see how the human eye perceives these images at different distances and angles. He noticed that the light traveled in straight lines and projected an image. He studied with different lenses and noticed the different images that each lens projected. He wrote a book called the Book of Optics, where he named the different parts of the eye, such as the retina, cornea, and of course, the lens. After the conclusion of his experiments, he theorized that it was just an optical illusion that was responsible for the differences in the size of the moon. The next innovations made with light theories came during the 17th century with Sir Isaac Newton and Christian Huygens. Huygens, a Dutch scientist, theorized that light is a wave and that multiple waves from different sources pass through each other and add their values. During our class, we have learned about how and worked with the ray model, which is a geometric model of light that explains concepts like how lenses focus on light, how reflections of light work, and how the direction of light can be distorted by certain materials such as water or glass. Huygens' discoveries of light waves help us to visualize the ray model and better understand the idea of wave interference that we've also heard about in class, the idea that it's possible for two waves to intersect when traveling on the same medium. Sir Isaac Newton, however, rejected Huygens' ideas and thought that light was composed of small moving particles. He worked with colors and discovered that clear white light projected visible colors. Both Newton and Huygens' theories of light paved the way for future scientists to make breakthroughs in science, despite their differences, such as Albert Einstein in the 20th century. For a long time, physicists thought that the speed of these waves of light were dependent on its source. In 1905, Albert Einstein proved these thoughts to be wrong. He found that the speed of light is actually constant at a speed of 3 × 10⁸ meters per second. He found that both Sir Isaac Newton and Christian Huygens were correct in their theories. Einstein put a name to the particles previously introduced by Newton. He called these particles photons, and he introduced his quantum theory of light. That light is a composition of small packets of energy that are called photons, and these photons also have a wave-like properties. These quantum theory of light is still accepted by scientists today, and these photons are still being studied. Thank you for listening.